Hello everyone, this is Anishu, and in the previous video I have explained you how I have implemented the persistence layer in my program. In this video, I'll cover the process of implementing dependency injection into my program and make it more decoupled. The problem with the previous implementation was that the controllers and the database were highly coupled, which can lead to multiple errors in our program. So we will be doing dependency injection to try and make our program more decoupled so that we can make it less error prone. To do the dependency injection, we will be first of all extracting the interfaces from our existing data classes and rename the classes accordingly. By using these extracted interfaces, we will be able to inject dependencies into our endpoint constructors, thus achieving inversion of control. This means that the responsibility of choosing a specific implementation is now outside of the endpoint. Before coming to the code explanation for this specific implementation of dependency injection, let me tell you that there is no specific changes done to any of the models for this implementation. That means the models will remain the same, but there are minor adjustments done in the program class as well as the controllers as we have injected dependencies. Now coming to the explanation of the interfaces that we have created for the dependency injection. First up, the iRobot command data access interface. This interface provides methods for interacting with the robot command entities in the database. With methods like getRobot commands, updateRobot command, insertRobot command, and deleteRobot command, we can retrieve, update, insert, and delete robot command entities respectively. Next, we have the iMap data interface. This interface handles interactions with the map entities in our database. Similar to the iRobot command data access, the iMap data access offers methods such as getAllMaps, updateMap, insertMap, deleteMap, enabling us to perform CRUD operations on the map entities. With the help of these interfaces, the controllers now will no longer need to directly operate on the data access classes, thus reducing a lot of coupling. Now coming to the ADO classes that I have created. First of all, let's take a look at the robot command ADO class. This class implements the iRobot command data access interface and provides method for CRUD operations on the robot command entities. It establishes a database connection using a connection string and executes SQL commands to interact with the database. The connection string contains the information about the database server, username, password, and the database name. The SQL commands are used to perform select, update, insert, and delete operations on the respective database tables. For this case, it is robot command. In this class, firstly, we have the getRobot commands method. This method retrieves all the robot command entities from the database. Using an SQL query, it fetches the data from the robot command table, creates robot command objects, and adds them to a list. Next, we have the updateRobot command method. This method updates an existing robot command entity in the database. It executes an SQL update command, modifying the name, description, isMove command, and modified date fields on the provided robot command object. Moving on to the insert command method, this method adds a new robot command entity to the database. It executes an SQL insert command, inserting values for name, description, isMove command, created date, and modified date fields. Lastly, we have the deleteRobot command method. This method removes a robot command entity from the database. It executes an SQL delete command, deleting the entry with the specified ID. With that, the explanation for the robot command ADO class is complete. Now moving on to the map ADO class. Map ADO class implements the iMap data access interface. Similar to the robot command ADO, this class handles the data access operations for the map entities. Again, it also utilizes a connection string to connect with the database and perform the CRUD operations. With methods like getAllMaps, updateMap, insertMap, and deleteMap, it performs CRUD operations on the entities. In this class, firstly we have the getAllMaps method. This function retrieves all map entities from the database. Using an SQL query, it fetches the data from the map table, constructs map objects, and populates them into a list. Next up, the updateMap method. This operation updates an existing map entity in the database. It executes an SQL update command modifying the columns, rows, names, description, and modified date fields based on the provided map object. Moving along to the insert map method, this function adds a new map entity to the database. It executes an SQL insert command inserting values for columns, rows, names, description, created date, and modified date fields. Lastly, we have the delete map method. This operation removes a map entity from the database. It executes an SQL delete command targeting the entry with the specified ID. With that, I have completed the explanation for the map ADO as well, and thereby completing the explanation for the ADO classes. Now, in the program class, we will be registering the data access interfaces and their implementation. By registering these services with the container, we establish the mapping between interfaces and their concrete implementation, allowing for seamless dependency injection throughout our application. Finally, in the controllers, we will be replacing the references to the direct data access classes with the reference to the interface. This will help the controller to decouple from the specific implementation of the database classes. Instead, it will now depend on the abstractions provided by the interfaces. There is no need to change anything else in our robot command controller and the map controller classes. With this, the explanation for the code is complete. Let me give you a brief demo of how it works. By running our application and executing the get endpoints, we can see that all the endpoints work perfectly fine. Similarly, when we are using a post endpoint or a put endpoints, we can again see that everything works just fine. Again, for the delete endpoint, we can see that it also works as intended. With this, we can see that our program is running accurately. But let's wait for a second and think back to our implementation. Have we decoupled everything in our program, or there are still some things that are heavily coupled? In the implementation that I just showed you, the code uses ADO.NET SQL data reader for PostgreSQL to manually map the fields from the database to the entities within the application layer. While this approach works, it's error prone and requires manual changes with every alteration in the underlying entity structures and leads to code repetition. To address these issues, the second implementation that I will be showing you introduces basic object relational mapping, or ORM. ORM automates the mapping process between the database tables and the application entities, reduces manual effort and potential errors. Instead of directly manipulating the SQL data reader, a generic method is introduced by common iRepository interface. This method leverages FastMember, a library that dynamically accesses information about the classes and structures at the runtime to automatically map data from database to entity properties. Extension methods are utilized to extend the functionality of NPG SQL data reader, which is used to fetch data from the Postgre database. Additionally, the new repository classes, that is the robot command repository and the map repository, are created to provide alterations to previous ADO classes. These repository classes implement both specific data access interface, that is iRobot command data access and the map data access, and a generic iRepository interface allowing for flexible data access and mapping. The usage of dependency injection remains, but now the endpoints interact with the repositories instead of specific ADO classes, further decoupling the code base and improving the maintainability of our code. To use FastMember in our program, first of all, we will need to install the FastMember library in our project. In this implementation, the controller folders will remain the same with no changes at all, while there will be a slight change in the models. In both the map and the robot command models, we will be adding a parameterless constructor, as this constructor will help us in generic type method contained in the iRepository that we will be creating. Coming to the extension methods class, this class defines an extension method called map2, extending the NPG SQL data reader class. It maps the data from the data reader to properties of the specified entity type using fast member. It iterates through the columns in the data reader, matches them to properties of the entity by name, and assigns value accordingly. This enables efficient mapping of database query results to entity objects. Now coming to the iRepository interface, which is responsible for executing database queries. It includes two methods: execute reader, which executes a SQL query and maps the result set to a list of entities of a specified type using an automatic ORM technique, and execute scaler, which executes a SQL query that returns a single value. The interface abstracts away the details of the database connectivity and query execution, providing a clean abstraction for data access operation in the application. Finally, in the robot command repository class, we implement both the iRobot command data access and the iRepository interfaces. It facilitates database operations for the table robot command. The getRobot command method retrieves all the robot command from the database. It fetches the robot commands using a SQL statement. It utilizes a repo execute reader robot command method inherited from the iRepository interface to execute the SQL command and map the results to a list of robot command object. Now the update robot command method. Here an existing robot command is updated in the database. It constructs a SQL update statement with parameters for the command ID, name, description, move status, and modified date. The method then executes this command using repo execute reader robot command. Insert robot command method. This method inserts a new robot command into the database. It prepares a SQL insert statement and with parameters for the robot command's name, description, move status, creation date, and modified date. After execution, it retrieves the newly generated ID using repo execute reader int. Delete robot command method. Finally, this method deletes a robot command from the database based on its ID. It constructs a SQL delete statement with a parameter for the command's ID and executes it using repo execute reader object. Overall, the robot command repository class encapsulates database operations related to robot commands, providing a clean and modular interface for interacting with the database while abstracting away implementation details. Similar to the robot command repository, the map repository implements map data access and iRepository interfaces. It encapsulates data access logic for interacting with the table map. The getAllMap method retrieves all the maps from the database table using a SQL select statement. Similarly, the update map updates an existing map in the database table. It constructs a SQL update statement with parameters for the map's ID, column, rows, name, description, and modified date. Again, the insert map method inserts a new map into the database. It prepares a SQL insert statement with parameters for the map's columns, rows, name, description, creation date, and modified date. Coming to the delete map method, this method deletes a map from the database based on its ID. It constructs a SQL delete statement with a parameter for the map's ID and executes it using repo execute reader object. Similarly to the robot command repository, the map repository class handles database operations related to maps, offering a clean and modular interface for interacting with the map data while abstracting away the implementation details. With this, the explanation for the map repository as well as the robot command repository is complete. Now we will go to the program CS and register the data access interfaces and the implementations for the repositories as well, and we will comment the previous registrations and then we will run the application. Finally, after running our application and executing all the endpoints in Postman, we can see that our program works just fine and as intended. With this, I have completely demonstrated dependency injection and object relational mapping. I hope you enjoyed the video and stay tuned for the next one. Thank you.